Welcome back to Remarkable. In this video, we're going to cover everything you need to know about HCF and LCM. Not just the basics, but all the different types of questions you can be tested on. We'll break down the key concepts first and then jump into past paper questions to see exactly how they appear in exams. By the end, you'll feel confident handling any HCF or LCM question that comes your way. Let's get started and make this topic completely remarkable. Let's begin with prime factorization. Okay, so prime factorization basically means breaking a number down into the prime numbers that multiply together to give you the original number. What is a prime number? A prime number is a number that is greater than 1 and that has only two factors, 1 and itself. Okay, so prime number is a number which is divided just by 1 and itself. It has exactly two factors. Okay, so now to prime factor, let's do an example. Okay, so let's choose 120. Okay, so you need to express 120 as a product of its prime factors. So what are we going to do? We are going to begin with the smallest prime number, which is 2. What do we get? 60, 30, 15. It cannot be divided by 2, so we're going to choose 3 as the next prime number, prime factor. 5 and 5, 1. Okay, so 120 can be expressed as 2 into 2 into 2 into 3 into 5, or you can write it in power form. So this is how you express a number as a product of its prime factors. Okay, and this is also known as prime factorization. Now, before I go on to touch upon HCF and LCM, I also want to go over another concept that I'm sure you're aware of, but a quick recap is always useful and helpful. Okay, so we're going to learn how to find the square root of a number using prime factorization. A simple yet powerful method that works beautifully, especially when the square root is a whole number. Okay, so let's begin with an example. So if you're asked to find the square root of 225, okay, so the first step is going to be that you're going to express this number as a product of its prime or factors. Okay, so 225, we're going to divide it by 5, 445, then 5 again, you get 9, 3, 3, 1. Okay, now because you're trying to find the square root, what you're going to do is that you're going to make pairs of 2. Okay, so this is one pair. This is the second pair. Okay, so and we're going to take 1 from each group. So 5 into 3, 15. So 225 is the square root of 15. Okay, I hope all of us are aware of this, and we know that if we're given a number, to find the square root of that number, we just express it in prime factor. We express the number as a product of its prime factors, and then we make groups of 2 or pairs of 2, and then we choose 1 from each group, and then we multiply that together to find the answer. This is for squares. What about cube root? So let's take another example. Maybe you're asked to find the cube root of 512. Okay, so what are you going to do? You're going to follow the same process. You're first going to express 512 as a product of its primes. It's an even number. Let's begin with 2. 2, 5, 6. 1, 2, 8. 64. 32. 16. 8. 4, 2, 1. Okay, but now because we are finding the cube root, we are going to divide or pair or group our factors in 3. Okay, so you're going to make groups of 3. So this is going to be the first group. Why? Because you're finding the cube root. Okay, this is going to be the second group, and this is the third group. Now we're going to take 1 from each group. So 2 into 2 into 2, which is 8. So 512, the cube root of 512 is 8. Okay, so please make sure that you're aware of how you can find the square root or cube root of numbers using prime factorization. Okay, now that the basics are clear, we are going to move on to finding the HCF and LCM of numbers using prime factorization. Okay, so this is a past paper question where in part A, they ask you to write 108 as the product of its prime factors. Okay, so this is an easy part, and it is of 2 marks. So we're going to be very careful. Okay, so 54 again 2. So whenever you have an even number, I would recommend that you should always start with 2. 27, not an even number, so we're going to divide it by 3, 3 and 1. Okay, so 108 is equals to 2 into 2 into 3 into 3 into 3. So you can also write it as 2 square into 3 cube. Okay, what is part B? So part B states that find the LCM, and I'm going to add, this was not part of the question, and HCF of 108 and 180. Okay, so we've already expressed 108 as a product of its prime factors. We are now going to express 180 as a product of its prime. And then I'm going to explain how we're going to use these prime factors to find the HCF and LCM. Okay, 180, so we'll begin with 2, 90, 45, 15, 5, 1. Okay, so 180 can be expressed as 2 square into 3 square into 5. Okay, let's copy this on the next page. So up till now, what we've done is that we've just expressed the two numbers as a product of their prime factors. Okay, paste. Okay, so 108 is this, and 180 is 2 into 2 into 3 into 3 into 5. Okay. Now I think most of you've learned the ladder method to find the HCF and LCM. And it is okay as long as it is a simple question. However, sometimes they just twist and turn the question. So the method that I'm going to teach you is helpful in such cases, okay? So now to find the HCF, first what you're going to do is you're going to make loops and hoops. So a factor which is present in both the numbers is going to form a loop, okay? So this is our first loop, second loop, third loop, fourth loop, and that is it, okay? And then the remaining ones with no pair factors, they're going to form hoops. Okay, so first hoop and second hoop. Now the general rule is that HCF is loops only, while LCM is loops plus hoops. Okay, so the HCF of 108 and 180 should be, and we're going to take one from each group. So 2 into 2 into 3 into 3. So it's going to be 2 square into 3 square. Okay, what about the LCM? So HCF is loops only. You're always going to make your loops and hoops at the start, okay? LCM is loops plus hoops. So first we're just going to copy down the HCF because that is loops only. And then what are we left with? The hoops. So it's going to be 3 into 5. So what is our LCM going to be? 2 square into, because we have another 3, we're going to add 1 to the power. 3 cubed into 5. Okay, so this is also a 2-mark question. It was a 4-mark question, a very easy 4-mark question to score. Okay, so I just hope that the concept is clear, that whenever they're asking to find the HCF or LCM, you're going to express the number as a product of their prime factors, and then you're going to make loops of common factors, and whatever is left is going to be, they're going to form the hoops. Your HCF is loops only, okay? While your LCM is loops plus the hoops, okay? I hope this is clear. And using this, we can also figure out a general rule that we can utilize in order to find the HCF and LCM of numbers. Okay, now what is that rule? Okay, so see what the power. Okay, let me use another color. Okay, so the factors of 108 are 2 square into 3 cube into 3 cube. The factors of 180 are 2 square into 3 square into 5. Okay, so the general rule is that HCF always takes the lowest power of the common prime factor. Okay, so here the power is same, so HCF has square. Here 108 has 3 raised to the power 3, while 180 has 3 raised to the power 2. So for HCF, we are always going to take the lowest power of the common prime factors, okay? While for LCM, we take the highest power of each prime factor that appears. So in case of 2, the power is same, so it's 2 square. Now let's compare 3. 3 is raised to the power 3 for 108, and here it's raised to the power 2. For HCF, we always take the lowest power of the factor. For LCM, we take the highest power of each factor. Okay? And here the power of 5 is 0, right? Because it doesn't exist. And here it's 1, so we're going to take 1, 5 in LCM. So this is an important rule. If you understand this, I think you would be able to solve very tricky questions easily. Okay? So HCF always takes the lowest power of the common prime factors, while LCM takes the highest power of each prime factor that appears. Okay? So we are going to keep this general rule in mind when we're going to solve some past paper questions later. Okay, let's do another past paper question very quickly. So they've given us B expressed as a product of its prime factors and Q as well. Okay, so they're saying find the highest common factor of P and Q. Okay, for that, what I'm going to do is that I'm going to write P in expanded form and Q right below it. Okay, so to find the HCF, what is the rule for HCF? Loops only, right? So let's formulate the loops first. So this is our first loop, then we have no more 2's, second loop, and then we make a loop for 5. Okay, so what is the HCF going to be? It's going to be 2 into 3 into 5. Okay, which is 30. Easy part? Okay, part B. Find the lowest common multiple LCM of P, Q, and 21. Okay, so we have P and Q. Now we are going to express 21 as a product of its primes. 7, so it's going to be 1. So 21 is 3 into 7. Okay, and let's first formulate the loops. Okay, so this is one loop, right? And then we also have, so the LCM is, first let's jot down the loops. So 2 into 3 into 5, and then the hoops, so 1, 2, 3. So we are going to have 2 into 2 into 5 into 3 into 7. Okay, so 1, 2, 3, 2 raised to the power 3, 1, 2, 3 raised to the power 2, 5 raised to the power 2 into 7. This is going to be your LCM. 2 cube into 3 square into 5 square into 7. Okay. Another way to go about solving this question that I want you to understand very clearly is that let's Okay, so P and Q are already written in power form. Okay, so I'm going to erase this for a moment. Okay. Okay, so this is P, this is Q, and 21 is 3 into 7. Now, what was the general rule for finding the HCF and LCM? LCM takes the highest power of each prime factor that appears. Okay, so what is the highest power of 2? It's 3, right? Here it is 1 and we don't have a 2 here. So 2 cube, then the power of 3 is 1 here. Here it's 2 and again it's 1. So we're going to take the highest power of 3. 3 square, the power of 5, the highest power is 5 raised to the power 2, and then 7, the highest power is 1. So this is what the LCM is. Okay, you can also go about finding the LCM using this general rule. Had they asked us to find the HCF, then we would have chosen the smallest power of the common factors. Okay, so the only common factor is 3. And what is the lowest power? 1. So the HCF in this case would have been 1. Okay, I hope this is clear. Okay, next, the next part asks us to find the smallest integer n such that p into n is a square number. Okay, so before we solve this question, I hope that you remember that square numbers have their factors in pairs of 2, right? So for a perfect square, all the factors are always in pairs of 2. Okay, so we're going to copy the factors of p, paste. Okay, so what is Pn going to be? So this is P, and P is being multiplied by N, and that N is here, and we don't know what the value of N is. However, smallest integer N such that Pn is a square number. So for square number, we need pairs of 2. So this is 2 into 2 into 2 into 3 into 5 into 5 into n. We need to find the value of n. Let's see how many pairs we have. So this is the first pair. This is the second pair, right? Now to make sure that p into n is a square number, we need a partner for 2, this 2, right? And then we need a pair factor for 3, and that's it. If we have these two numbers, then Pn is going to be a perfect square. So the value of n is going to be these. So n is going to be 2 into 3. Okay, because if n is 6, then we can make sure that all the factors are successfully divided into pairs of 2. If there's any confusion, please rewatch this part. It should make sense to you. But if the confusion persists, please feel free to drop in a comment or a message and I will get back to you. Now, had the question asked us to find the smallest integer n such that Pn is a cube number. Okay, so let's change the question and see that if in place of square, the question asked us to find the value of n such that Pn is a cube number. So I again hope that you remember to find the cube root, we need to group our factors in pairs of 3. Okay, and that is what we're going to do here. So P into n is equals to 2 into 2 into 2 into 3 into 5 into 5 into n. Let's make groups of 3. So 1, and that is it. Okay, we have 1, 3. We need 2 more 3s to make a group. And then we have 2 5s and we need 1 more 5 to make a group. Okay, so what is the value of n going to be? N is going to be 5 into 3 into 3, which is 45. 9 into 5 is 45. Okay, so for squares, we're going to make sure that the factors are in group pairs of 2. For cube, we're going to make sure that the factors can be grouped into, can be formulated or divided into groups of 3. I hope this is clear. Now let's do a slightly tricky question. This question might seem tricky, but if you follow the rules and the understanding of what has been taught, you should face no difficulty in solving it. Okay, so here they've given us m as a product of prime factors, but the powers of the factors are in terms of x and y. Okay, so m has been expressed as a product of its prime, n has been expressed as a product of its prime, and they've stated that the lowest common multiple of m and n is 2 raised to the power 8 into 3 into 6 into 5 raised to the power 2 into 7. Okay, so this is the LCM. And they've asked us to find the values of x and y. Okay, now what is LCM? LCM is loops plus hoops, or what is the rule that we've learned? LCM is the highest power of each prime factor that appears. Okay, so let's see. 2 raised to the power 8. The power of 2 here is 3, so it means that 2x is basically equals to 8. Okay, so 2x is equals to 8, x is equals to 4. Okay, why? Because LCM takes the highest power of each factor. So 2 raised to the power 8 means that since this is 3, the power of 2 is going to be 8 for m. So we're just simply going to equate 2x is equals to 8 and we have x is equals to 4 as the answer. Okay, next, 3 raised to the power of 6. Okay, so this is 3 raised to the power 4. It means x minus y is going to be 6. Okay, so x minus y is going to be 6. We know that the power of x is 4. 4 minus y is equals to 6. Minus y is equals to 6 minus 4, 2. So y is equals to negative 2. Okay, so the value of x, according to the rules that we've learned, is 4, and the value of y is negative 2. Okay, let's do another similar question to ensure that there is no confusion left. Y raised to the power 4, where x and y are prime. Find the HCF of P and Q. Give your answer in terms of x, y, and n. Okay, so according to the rule that we have learned, HCF is always takes the lowest power of the common prime factors. Okay, so the lowest power of common prime factors. So x and y both are common. So is x raised to the power n bigger or x raised to the power n minus 1? So it's like, is it 2 raised to the power 3 or 2 raised to the power 3 minus 1? So this is always going to be the lower power because it is subtracting 1 from this power, right? N minus 1. So obviously this is going to be smaller than x raised to the power n. So in HCF, we're going to take x raised to the power n minus 1, and this is y square, and this is y raised to the power 4. So what are we going to choose? We're going to choose the lowest power, which is y square. Okay, so this is the HCF of P and Q. For this, you need to be absolutely clear about this rule. This is really going to help you in solving such questions. So for HCF, you're always going to choose the lowest power of the common factor, while for LCM, you're going to take the highest power of each prime factor. Now the last way where they can trick you or ask you a question where you might find a little trouble in understanding is where they give you the HCF or LCM and they ask you to find one of the numbers. So, for example, if they tell you that the HCF of 96 and a number n is 2 into 2 into 2 into 3, okay, and they've also given you the prime factors of 96, 2 into 2 into 2 into 2 into 2 into 3, okay, and the question states that given that n is less than 96, so let's write these conditions down. Given that n is less than 96, find the greatest value of n. Okay, so they've capped it at 96. So we need to find the greatest value of n, which is less than 96. Okay, HCF. HCF has basically the lowest power of the prime factor, right? So the HCF is 2 cube into 3. So it means that we have 3 loops here, right? So it's 2 into 2 into 2. And then we have a 3 left, so we are also going to have a 3 here, right? So what do you get? We get 3 into 2, 6, 6 into 2, 12, 12 into 2, 24. So we need to find, so you have to be careful here. They're specifying that we need to find the greatest value of n that is less than 96. Okay, so according to our, because they've given us the HCF and we have formed the 4 loops, 1, 2, 3, 4, the 4 loops. Now, what the numbers that we can add to n, we can add prime numbers to n. So n is 2 into 2 into 2 into 3, and we can add anything else to n as long as n does not exceed 96. It is a prime number, and no new loop is being formulated, right? So, for example, if we add 2 here, we add 2 here in n. So 2 is going to make another loop, and this loop needs to be added in the HCF. So this won't work, okay? So you have to make sure that no new loop is being added. Okay, so what are the numbers that we can add? So we can add 3 or 5. Okay, so 24 into 5 is 120. It exceeds 96, so this is not an option, right? What about 3? If we multiply 24 with 3, we get 72, which is less than 96. Okay, so we can add a 3 to our number n, because that is not going to make a new loop, and it is still going to maintain the HCF that is given to us in the question, and n is less than 96. Okay, we cannot multiply it with 2 because that will make another loop. If we multiply with another 3, then it exceeds 96. So what is the value of n going to be? N is going to be 2 into 2, 4, 4 into 2, 8, 8 into 3 is 24, 24 into 3 is 72. Okay. They can also give you the LCM and ask you to find the other number. Okay, so let's do an example, a past paper question for this. Okay, so the question states that the LCM of a number. Okay, let's first write down the numbers. Okay, so LCM of number 1 is 2 square into 5 square into 7, and another number, into the LCM is 2 square into 5 square into, no, sorry, 2 square into 3 into 5 square into 7 square. Okay, and they're asking you to find the lowest value of n2, the lowest value of n2. Okay, so it means that we would try our best to add the least number of factors for this number, for n2, right? Okay, LCM takes the highest power, right? So since it has 2 square, we're going to assume that this 2 square is from the first number. Okay, and we're not going to add anything to n2. Let's move on to the next factor, 3. We don't have a 3, but the 3 exists in the LCM, so we will have to add it here. Okay, on to the next factor, 5 square. We have a 5 square in the first number, in the factors of the first number. So we are going to assume that it's coming from the first number. Okay. Next we have 7 raised to the power 2, 7 square. And here we have 7 raised to the power 1. So what does it mean? It means that n2 is going to have 7 raised to the power 2, because the LCM always chooses the highest power from the factors, so we're going to have a 7 square here. Okay, so what does our number become? It becomes, n becomes 3 into 7 into 7, which is 147. And that's it for now. I really hope everything is crystal clear. With your exam just around the corner, this is the time to believe in yourself, because I believe in each one of you. Stay focused and please trust your preparation. You've come this far, and just with a little more revision, you're absolutely ready to ace your math exam. So go in with confidence and give it your best. As always, if this video helped, don't forget to like, subscribe, and share it with a friend who might need that last minute boost. You've got this, and I'm rooting for all of you. Good luck, and see you in the next one on Remathable.